All right, your first old school is going to look a little something like this, where we practice some of the most important things or formulas that need to be known for this class and future classes and the SAT and the ACT. So, number one, write the equation of a line that passes through the points 2, 0, and negative 5, 3. So, it's actually, I think, the fastest is to know the formula, the point slope formula, which is y minus y1 equals m times x minus x1, where you just plug in the slope for m and take either one of these points and plug it in for x and y, like x1 and y1. So to first find slope, you need to do a good old-fashioned y minus y, 3 minus 0, over x minus x, negative 5 minus 2. So my slope for this one is going to be 3 over negative 7. Okay, so that's going to replace the m that's here. So let me slide that sucker in there. And then I need a point to go in for x1 and y1. So I'm going to choose this one because it just looks easier. So a 0 is going to get plugged in for y, and a 2 is going to get plugged in for that x1 over there. And pretty much you could stop here if you want, or if you want to go into y equals mx plus b form, just distribute. So this will be y equals negative 3/7 x plus, let's see, it's going to be plus because negative times negative, 6/7. So remember multiplying fractions, top times top, bottom times bottom. This is like having a 2 over 1. So that would be how I would write my final equation. Oops, that's a 6. Okay. The next one, find the length of the hypotenuse of triangle ABC given these three vertices. So let's see, length. Length should trigger distance. So you could either use the distance formula if you can figure out which part of this picture is the hypotenuse, or you could just do Pythagorean Theorem. I'm a Pythagorean Theorem girl, which, by the way, that's where the distance formula comes from, right? A lot of you already know that. So let me just do a quick sketch so I know what kind of triangle, like which way it's facing. So negative 1, 3 would be my A. 4, 3 would be my B, and then my C is 4, 8, so it's up here somewhere. Okay, so the reason I like to kind of draw this out either in my head or literally on paper is because I can see that this is where the right angle would be just by the orientation. So what I'm looking for here is the length of AC. Now, like I said, you can do the distance formula between A and C if you still remember the distance formula. I'll write it over here in case you want to go that route. This, by the way, is a big deal on the SAT, ACT. It shows up. So if you're quick at it, roll right into that formula. That's a plus sign. All right. But I've already drawn this out. I'm going to use Pythagorean Theorem. So to get from A to B, it looks like a horizontal distance of 5. To get from B to C, it looks like a vertical distance of 5. And then I'm looking for the hypotenuse. Well, I could either do 5 squared plus 5 squared, oops, equals c squared. Remember the Pythagorean Theorem? And I could go from there. Or if you remember that the two, this is a 45, 45, 90 triangle, and I know that because these two legs are congruent. And anytime you have congruent legs, the triangle sides relate to each other as being x, x, and this one is x root 2. So like I already know the answer is going to be 5 root 2. If you know this was a 45, 45, 90 when you saw those two 5s. If you didn't, you would end up getting 50 equals c squared here. Then you'd have to take the square root of 50. Then you'd have to break this guy down just like in the good old days, and it would in fact turn into 5 root 2. So I took a lot of time explaining that one. It's because you have so many choices. I had 3 different ways I could have done this problem, and I wanted to show you all 3. Moving on, let the given graph below be f of x. So this is f of x. Part A, sketch the vertical reflection of f of x. So you have to know what a vertical reflection is. Vertical means you're reflecting it up and down. So it actually means that it's across the x-axis, because if you kind of think vertically up and down, it's going to flip across the x. So what I'm going to do is just, this looks like the x-axis here, so this point will stay the same, and I'm just going to kind of mirror. So this right here is going to come down and look something like that. This piece here is going to, oh my gosh, that's terrible. Okay, oh my god, I'm butchering. Okay, I'm on a really weird surface, kids. Cut me some slack. All right, let's do like, okay, that's a little bit better. But to be more accurate, you might want to just take this point and make sure you count down and that it matches that one. This would be a good point to match up to here, and then kind of fudge your graph after that. So, sorry, that's terrible. All right, now I'm going to erase it so I can do part B. Part B wants me to go back to the original graph, f of x, and now subtract 3. Well, if I'm subtracting 3, it's like taking the y values and subtracting 3. So all of these get shifted down. 1, 2, get down by 3. 1, 2. I'm just going to take a few key points here, and then just something like that. There we go. So just take a few points, shift them down, re-sketch your curve, and you'll have that right. I should have made this a little bit more drastic here to match what's above. Okay. All right, moving on to number 3. Sketch the graph of 2x plus 3y equals 0. So many ways to do it. You can make a chart and start plugging in points and finding the other one. I just have always, my whole life, been a fan of getting y by itself, like I'm programmed that way. So I'm going to move the 2x to the other side. I'm going to divide both sides by 3. And the reason I like this way is because I can view it as a mx plus b, right? Which means I know this is my slope and my y-intercept is 0. So I'm going to start at 0. And the slope is negative 2/3, so down 3. I'm sorry, down 2 over 3. Down 2 over 3. This is the easiest way for me. And then I'll get 3 good points and then fudge the rest of the way. There we go. All right, and number 4, the last one on our old school, domain and range. So this is making sure you understand bracket versus parenthesis. Remember, open circles, parentheses, brackets are closed circles, and you can definitely use interval notation here. Let's go left to right and see what happens. So my graph is definitely starting at -9, and then I come across. Okay, right here, do you see how there's an overlap? That's a good thing. It means I don't need a separate interval. So I'm just going to keep going. Do these overlap? No, these do not overlap. This looks like it stops at about 2, and this one picks up at 3. So what I'm going to do is let this first stop at 2, put a parenthesis because of the open circle. The skinny u sort of means like union with or combined with, joined with. Now I'll pick up my next interval at 3 because that's where that hits the x-axis, and then it stops at maybe 6. Another bracket. Why a bracket? Because of the closed ends. Okay, so there's domain. Now range, we have to look at this from the y perspective, right? So I'm going to find the lowest y on the graph. So it looks like 2. 2 is the lowest y on the graph. So my range starts at 2, and then it goes up to 4. I think it looks like that stops at about 4. Now, where does it pick up again? Well, it picks up at 5. Doesn't that look like those are about at 5? So we have to account for this gap right here. That's why you see me stopping the first interval and then picking up the next one. The 5 is going to have a parenthesis because of the open circles, and it tops out at 7. Closed bracket. So that should not be new to you. You should have done a lot of domain and range in the past, but you might be a little rusty, and so that's just a little refresher. Hopefully these are concepts you kind of remember, and you might just need it a little refresher. If you need help, come in. We'll make up some problems similar and see if you can do it by yourself, and then I'll look it over with you and make sure you're doing it right.